Okay, this video is for all graphs and their equations. So this first one here, we want to determine the equation of each line and describe what the line shows. So the first one I'm going to find is for line S. So I need to choose 2 points on that line. So one point is 0, 0. And the other point I'm going to use is 21. Sorry, 20, 100. So our general equation of a line is y equals mx plus b, where m is our gradient and b is our y-intercept. So here, our gradient is our change in y over our change in x. So what I can do is I can label my brackets x1, y1, x2, y2 as their ordered pairs. And then what I do is I substitute that information into this formula. So I've got 100 minus 0 over 20 minus 0. So that's going to be 100 over 20, which is 5. So I now have y equals 5x plus b. Now to find b, what I can do is I can substitute in one set of coordinates. So if I choose to sub in coordinate set 2, which is 20 and 100, I substitute those into x and y. So what I then have is I'll have 100 equals 5 times 20 plus b. So we now have 100 equals 100 plus b. Now to move the 100 to the other side, I need to subtract 100. And so 0 equals b. So my y-intercept is at 0, and that we can confirm that by looking at the graph because our line hits the y-intercept at 0. So what that means is the equation is y equals 5x. Now, my second line is line M. So I'm just going to erase this little bit here. So line M, the coordinates I'm going to use, again, 0, 0, and then I've got 20, 40. I can follow the same process, so my equation of a line is y equals mx plus b. So I'm going to have, or I want to determine what is my gradient. So that's the change in y over the change in x, or rise over run. So we're going to have 40 minus 0 over 20 minus 0. So our gradient is 2. Now I can look at this graph and I know the y-intercept is 0. So what I can do is I know straight away that my equation is just going to be y equals 2x. The last part of this question is it asks you to describe what does the line show. Well, the line shows that on line M, if I travel for 5 seconds, I'm going to have travelled 10 metres. Whereas for line S, if I travel for 5 seconds, I will have travelled 25 metres. Okay, we're going to have a look at worked example 3. So we're going to find the equation of a few of these lines and then the rest are on the worksheet. So what we're going to do is for the black line. Okay, so what we can see is that with this black line, it is a horizontal line. So what this means is that no matter what the value of x is, the value of y always stays the same. So the gradient of this line, if we were to work out, okay, well, what's the change in y over the change in x? Well, our change in y is nothing. So if we have a numerator of 0, and then no matter what the value is in the denominator, obviously it cannot be 0, well then our gradient is going to be 0. So if I had my equation in the format of y equals mx plus b, if my gradient's 0, that's y equals 0x plus b. That's automatically going to cancel out x because 0 times x is 0. Now remember, my b is my y-intercept. So where does this line cross the y-axis? Well, it crosses at 7. So what that means is the equation of this line is y equals 7. On a similar note, we have our red line. Now our red line is a vertical line. So if we were to do our change in y over our change in x, you can see that for no matter what the value of y is, our x always stays the same. Now our change in y, if we went from 1 to 3, would be 2, but our change in x would be 0. Now, because we have 0 on the bottom of the fraction, what that means is our gradient is undefined. So an undefined gradient means that it doesn't exist. So what this then means is that here our equation will be x equals -5, because no matter what value you plug in for y, x is always going to be -5, as that is where it crosses that x-axis. Okay, and our third example for this one here, we'll find the equation of the blue line. So if I find the equation of that blue line, I want to know, okay, well, what is 2 points on that blue line? So you want to try and find points that line up exactly so that you have as precise coordinates as possible, as this will be as accurate as possible. So I'm going to choose these 2 points here. So these 2 points are -4, -5, and 6, 0. Okay, the first thing that I need to find is what is the change in y over the change in x, or what is the gradient. So you can write as change in y over change of x, or you could write y2 minus y1 over x2 minus x1. Our next step that we need to do is we can label our coordinates. So if I've got x1, y1, x2, y2. So if I substitute those in, I'm going to have 0 minus -5 over 6 minus -4. Now remember from last year that if you minus a negative, it becomes a plus. So we've got 0 minus -5, so that's going to equal 5. And 6 minus -4 is 10. So here our gradient is going to be a half. Sorry for the colour change halfway through. So if our gradient is a half, what that means is when I write my equation, I've got y equals a half x plus b. Now I can look at that line and I can say, oh, yep, I can see that the y-intercept here, it crosses the line at -3. But let's just double check that that is the value. So I choose one of my coordinates and I substitute that into the x and the y value. So I'm going to choose that first ordered pair. So that would mean that I've got -5 equals a half times -4 plus b. So -5 equals, now a half times -4 is -2 plus b. To move -2 to the other side, I need to add 2 so that it cancels out. So I add 2 to that other side, and -3 equals b. So you can see our y-intercept is -3, as we read from the graph. So our equation would be y equals a half x minus 3.